Hello. In this assignment, we will be going over exponential decay, specifically something called half-life. So, since this is still exponentials, that means that we are still multiplying, and that also means that since it's half-life, it's something about multiplying and something about multiplying by a half, right? So the numbers are still going to be going down, right? So you'll notice all these numbers, they decrease because that's decay, and something about halving, okay? But we need some background about what half-life is, so I'm going to read this paragraph. So when you take a medication or any substance, for example, coffee, the medication slash substance, it enters your bloodstream. And so, for example, when you drink coffee, the caffeine, it enters your bloodstream through your stomach. Drink it, goes to your stomach, absorbs through the stomach. So when the caffeine is in your bloodstream, you feel energized. But that caffeine doesn't stay in your bloodstream forever. So, over time, the amount of caffeine that leaves the bloodstream and the effects of the caffeine start to wear off. And every compound and substance, it wears off at a certain rate. Okay, so this rate is this half-life thingy for exponential decay. And so science, in general, uses this term half-life to measure how fast a substance is wearing off. And specifically, wearing off, decay, going down, and in this case, it's the amount of coffee or caffeine in the bloodstream. And so caffeine has something called a half-life of a certain time. So when it says that caffeine has a half-life of 5 hours, and you can look up different substances, they all have different half-lives, that means that after 5 hours pass, the amount of caffeine cuts in half, so multiplies by 1/2. That's why it's called half-life, right? So 5 hours pass becomes half. Another 5 hours becomes half. Okay, and so the official definition, half-life is the amount of time that a substance becomes half of the original amount, right? So really, we're just multiplying by 1/2 a bunch of times. Nothing too fancy here. So let's say you ingested 300 milligrams of caffeine. That's 1 to 2 to 3 cups of coffee maybe. So we have 300 at the beginning. And so let's remember this is half-life, right? So all the values or multiplier is always going to be 1/2, right? So the only measured values, 300 times 1/2, it's going to be 150. We multiply by 1/2, it's become 75, multiply by 1/2, and we get 37.5, right? So we know that these are the amounts, but how long does it take to get there? Well, remember, caffeine has a half-life of 5 hours, so whatever the half-life is, that's what we add to the hours. So after 5 hours pass, we get half, right? 300 to 150. Another 5 hours pass, 5 plus 5 is 10, and this has become half again, right? Another 5 hours pass, this becomes 15, so after 15 hours, it halves again, 75 to 37.5. So that means that how much left at each time? Well, after 5 hours, there is 150, right? After 10 hours, there is 75 milligrams left. And then after 15 hours, there are 37.5 milligrams left. And so, to answer these questions up here, 75 and 37.5, right? So basically, this table will allow us to solve every single problem. Okay, so with each example, we're going to set up the beginning amount, multiply by 1/2, and then count up by the half-life. So acetaminophen, also known as Tylenol, has a half-life of 3 hours. So if you take 200 milligrams at the very beginning, we want to know how much is left after 3 hours, 6 hours, 9 hours, right? So we know that since it's half-life, we're multiplying by 1/2 a bunch of times. 200 times 1/2, that gives us 100. We multiply that by 1/2 again, we get 50, right? We can multiply that by 1/2, 25. And how long does it take to get there? Remember, the half-life is 3 hours, so that means plus 3 here. So 0 plus 3 is 3, so after 3 hours, there are 100 milligrams in your system. After 6 hours, 3 plus 3 is 6, there are 50 milligrams still in your system, and after 9 hours, 6 plus 3, 9, that's going to be this value here. That gives us 25 milligrams left. And so this has lots of implications for caffeine and making sure you don't have caffeine too late in the day because it's still in your system. A couple more, ibuprofen has a half-life of 2 hours, so if you take 400 at the very beginning, we know that the half-life length, we're going to add that amount, so plus 2 hours after 2 hours pass, this becomes 1/2, right? So if it's asking us the amount after 6 hours, we'll keep adding a half-life until we get to 6. So it's after 2 hours. At another half-life, that's 4 hours. At another half-life, that is 6 hours. So 400 times 1/2, 200. Times 1 over 2 is 100. Times 1 over 2 is 50. So after 6 hours, there are 50 milligrams left. And lastly, carbon. Carbon, this is a good, it's a measure of life, biology. So it has a half-life of 5,730 years, and we have 10 pounds at the very beginning. Has a half-life of 5,730, and we want to know how much is left after 11,460. So when we add one half-life, we get to this many years. We add another half-life, and what do you know? It comes out perfectly to 11,460. Right, so 10 times 1/2 is 5 pounds, times 1/2 is 2.5 pounds. So after 11,460 years, there are 2.5 pounds remaining. Thank you for listening.